Okay, hello everyone, and thank you for being here. My name is Tiejun Chen. I'm from VMware Octo, Office of the CTO. One of the group over there, that's ATJ, Advanced Technology Group. Our group focuses on near-term co-innovation through a better alignment with and collaboration with our R&D product team and even our custom and partner. Basically, we are trying to incubate emerging technology solutions. Especially on my side, I'm working on edge computing, machine learning, modern application, edge, even on SmartNIC. This is the area of my interest. Right here, today I'm going to talk something about machine learning. Let's attach GPU anywhere with vSphere Bitfusion Extension. I hope this is your interest too. At first, I need to make this required disclaimer for all presentation. This presentation may contain product features or functionality that are currently at development. This overview of new technology represents no commitment from VMware to deliver these features in any general available product. Features are subject to change and must not be included in contracts or purchase orders or sales agreements of any kind. Technical feasibility and market demand will affect final delivery. Pricing and packaging for any new feature, functionality, technology discussed or presented have not been determined. Okay. Now let's go through today's agenda. First of all, I'd like to give you a brief overview of vSphere Bitfusion to help you understand what our vSphere Bitfusion is. Next, I'll talk a bit of our Bitfusion extension. After that, with our Bitfusion extension, how to attach GPU anywhere, to edge, to multi-cloud, and even to SmartNIC. The last part is our video. Okay. So VMware vSphere Bitfusion is our machine learning product. It can help attach GPU any host in the cluster. It works by intercepting CUDA call via CUDA API at runtime and sending them across network to be processed in the GPU. VMware vSphere Bitfusion contains several components, including client, group, manage, etc. But actually, VMware Bitfusion just utilizes a client-server model. The client just runs your machine learning AI workload, and the server provides that hardware acceleration. So vSphere Bitfusion, just like it can trick your client into thinking it has a local GPU when the GPU in fact on the EX server. That's about vSphere Bitfusion. vSphere Bitfusion just like can virtualize the physical GPU hardware from EXI host and aggregates them into a single pool of GPU resources. We also use some technology like RDMA, InfiniBand to accelerate the Bitfusion process. But Bitfusion product has some limitation. One is it requires the server and client have to be deployed on the same CPU architecture. That's x86. So I was thinking, what if we can enable vSphere Bitfusion to other CPU architecture like ARM64? That's about our Bitfusion extension. Next. So we'll put some time and efforts to enable Bitfusion to ARM64. Now we can attach GPU from ARM64-based server to ARM64-based client. Actually, with our extension, vSphere Bitfusion can run over heterogeneous architecture. Bitfusion server can be deployed on one CPU architecture. Bitfusion client can be deployed on another CPU architecture, the different CPU architecture. For example, now Bitfusion server can be deployed on x86, but the Bitfusion client can be deployed on ARM64. So it's our Bitfusion extension. So what we can do to help us attach GPU to anyone? I want to talk about Edge AI at first. Now, edge computing is one hot topic. So it's very hard to have any edge conversation without hearing Edge AI. Actually, Edge AI is the top one edge computing workload. Typically, we'd like to distinguish edge AI from edge computing in the need to run a variety of machine learning with a predictive and prescriptive model that require more power computing environment with specific CPU and memory and storage and even some hardware accelerator. But actually, there are many challenges around putting edge AI in the real world. Most edge systems are resource constrained. They are small boxes. They have limited install space or power supply. These legacy systems are still produced, and even in the production, they are already deployed remotely. So it's hard to enable edge AI. It's not easy to upgrade them or replace them with a more powerful computer platform. A variety of edge AI accelerators have been introduced, but they are from different vendors. The architecture are heterogeneous, and especially not different from that cloud accelerator like GPU. So you cannot use those traditional machine learning frameworks, TensorFlow or PyTorch. And once you deploy the edge AI accelerator, it's hard to scale up them. In industry edge system, you have to consider meet some hardware software requirements like thermal cooling and even safety requirement. It's very hard for edge AI accelerator. Machine learning training. Machine learning at the edge nowadays is very small but non-zero. Even there's a merging trend for running federal learning and training model at the edge to address data privacy and data sovereignty issues. But unfortunately, these edge AI accelerators cannot support that machine learning training. They are specific to that machine learning inference. Back to user custom, they want to deal with machine learning hardware software maintenance. Another trend I want to mention here is that 5G MEC. With 5G MEC, the edge infrastructure runs within the facility of co-located provided by the telecom provider, co-located that mini data center nearby that customer or even nearby that cell tower. So for this problem or challenge, even new trend, what's our solution? We plan to attach that remote AI accelerator for any application at edge. Here, now we deploy Bitfusion server on enterprise on-premise server or either on F5G is the MEC platform provided by that telecom vendor. And then we deploy Bitfusion client on remote edge system, including IoT edge gateway, endpoint on IoT endpoint device, and other edge system if possible. So now we can attach GPU from this server to this remote edge system. Typically, on these servers are based on x86. The client can be deployed on either x86 or ARM64 with our Bitfusion Extension. In this case, we leverage some open source projects like EdgeX Foundry, it's a common open edge computing project hosted by Linux Foundation, and ROS, Robotic Operating System. We also introduced TVM to boost our machine learning inference performance. TVM is that open source machine learning compiler framework for diverse platforms. It aims to optimize deep model to more effectively used on diverse platforms. We also build our solution into a project EXE, let's add EXI. EXE is light with small footprint and low memory overhead. More importantly, it can support edge network connectivity protocol like Wi-Fi and IoT. This can help us deploy our solution to a more than edge system. It's about a demo environment. I have the Wi-Fi route. I connect everything to this Wi-Fi route. The first one is the x86 based server. Install the GPU, NVIDIA GPU 1080i. I have an IP camera to help us capture image as input source. I have a Raspberry Pi 4. It represents edge system. I install the EXI on the Raspberry Pi. I use my cell phone to log into that EXI to check something, including that machine learning result. The key point here is now we can attach GPU from x86-based server to Raspberry Pi to accelerate that AI workload running on Raspberry Pi. This is a video demo. Let's go. So the right back is that Wi-Fi router. Here is my x80 based PC. I install GPU 1080i, IP camera with small box is that Raspberry Pi. I already deployed EXE on top of the Raspberry Pi. You should realize is a packaging what connected through the Wi-Fi. Now I just pick up my cell phone to log into that EXI running on top of Raspberry Pi. Okay, so like what we do with the EXI client on the server, you can use my cell phone to get the system information and the EXI information on this target. Okay, that's it. After that, I will jump to one VM running on top of the EXI. And you see here, I'm already run my AI workload. That's Euro 3, one typical object detection model. So in this window, you can see the TV monitor and the card and the clock can be identified. You should remember this machine learning inference was accelerated by that remote GPU in the GTX 1080i on that x80 based PC. Okay, it's out that edge. Let's go back to that cloud. I'm talking about modern cloud infrastructure with the introduction of ARM64 due to the energy and cost saving and even high efficiency in many cases. Even talk about that ARM64 based system ecosystem. Now you can find multiple vendors like some giants, big computing, NVIDIA, and even that new power architecture on V9 has been introduced this year. In the production, in the public cloud, you also can find that servers. Microsoft has made no secret. It wants to have 50% of its server capacity on ARM processor. They have started deploying this internally. Amazon based on Amazon Graton is quickly expanding its EC2 footprint. Amazon Graton 2 based EC2 instance make up 40% of the install based within Amazon EC. Amazon. About 50% of Amazon EC2 instance addition in 2020 are based on Amazon Gravity 2. So here I want to see, modern cloud infrastructure, especially modern machine learning cloud infrastructure, AI machine learning cloud infrastructure, will be on ARM64 as well as x86. They can coexist if necessary. So in this case, at first, besides our packaging Bitfusion client to container and the traditional guest OS, traditional VM, we plan to package Bitfusion client into our CRX container runtime for EXI. In order to support that vSphere with Kubernetes towards our Tanzu project. On the bottom, now we can set up that GPU resource pool among x86 and ARM64. Client also can be based on x86 or ARM64. So we can attach that GPU among the different architecture. So it's awesome. And it's just like a hybrid server and hybrid client. Here's the demo environment. I use two targets. One is ARM64 based MP server on the left side. Another one is an x86 based target. I will show I can attach GPU between these targets. Here's the demo. Actually, there are three parts. The first part, install GPU on ARM-64 based MP server. The GPU is NVIDIA GPU GTX 1080i, boost Bitfusion server. These are the Bitfusion server address. The packet actually use another ARM64-based packet, like Raspberry Pi. The different IP address. And then I use that Bitfusion client to attach GPU from ARM MP server to this Raspberry Pi. I run at a typical TensorFlow benchmark based on model Net 50. Now I just stop here and show some information to approve. It can run very well. Yeah, as you see here, it can run perfect. And even we can use Bitfusion client, get that remote GPU information on the Raspberry Pi. This is the first part. The second part, I still use that MP server installed GPU in the GTX 1080i. And boost this server and check that host address, and then jump to that target. But this time, I use x80-based target, a different IP address compared to XR host. Okay, now we're again just get that remote GPU information on the x86-based target and run the typical TensorFlow benchmark again. But this time, it happened on that x80-based target. Okay. The third part, I deploy that Bitfusion server on x86 and deploy client on ARM64. Now I attach the GPU from the x86-based PC to the Raspberry Pi and run that workload TensorFlow benchmark. So I want to say here now, I can attach GPU from x86 to ARM64. I can attach GPU from ARM64 to ARM64 and even to x86. There's nothing different in that performance. Next part, I want to talk about one specific thing about that SmartNIC. Here, I don't want to talk more on SmartNIC or our project module. You can get more information from other sessions. Okay. So back here, SmartNIC, basically we can use SmartNIC to offload some work functionality like network, storage, and security from host to SmartNIC in order to free up host CPU cycle to help us run more than user application on host. Okay, so VMware had a great project module that was announced last year, VMware. Basically, we have EXI running on SmartNIC on the embedded processor and not at host. Okay. So at first, I want to mention some new SmartNIC, like NVIDIA Converged Accelerator. It brings together the power of NVIDIA GPU 800 and the traditional EPU Bluefield 2. For that RPG, someone puts RPG into this PCIe card. Here is one example. They put that links LeonQ actual scale and MP source RPG into this PCIe card. This RPG can be programmed to provide that GPU, deep learning process unit, that can help accelerate your machine learning inference. For Intel, Intel had various types of SmartNICs, but typically they just attach their FPGA to the processor. That can be x86, also can be that ARM64. But potentially, the FPGA can be programmed to that machine learning API. Okay. So for this new SmartNIC, what we can do? Actually, SmartNIC are being deployed to support AI machine learning workload. In our case, we deploy Bitfusion server on SmartNIC, not host. And then we deploy Bitfusion client on local host, or even remote host. It can be based on x86 or ARM64 in the cluster. And now we can attach GPU from this SmartNIC to any host in the cluster. This solution has a great advantage. If the host somehow compromised, our SmartNIC still can help our VCF or VMware Cloud Foundation to provide AI functionality to any host, any application in the cluster. Maybe you want to talk about other SmartNIC, the traditional SmartNIC without any AI engine. We also can do something with our vSphere Bitfusion Extension. In this case, we deploy Bitfusion server on host. We deploy Bitfusion client on SmartNIC. Then we can attach GPU from host to SmartNIC to accelerate something. On the one hand, it can accelerate some services like NFV or network service. Maybe you can help us identify that malicious activity, abnormal behavior. On the other hand, even now we can deploy that AI workload on SmartNIC, not host, and even we can migrate on AI workload from host to SmartNIC in any case. I think that's a promise in solution. I also have on the demo. I will show I can attach GPU from x86-based host to this Intel BSA SmartNIC. About attach GPU from SmartNIC to host, we are waiting for the hardware available, but technically it's not a problem. Okay, in the video. On the black background, that's from that EXI running on at the host. I deploy the Bitfusion server with that in the GPU to get 1080i. This EX client from that SmartNIC, Intel BSA SmartNIC. I installed one service VM and then run that TensorFlow benchmark on this service VM. But that was accelerated by the GPU from host. Okay. The last part is about some takeaway. In our project, I think our solution can offer consistent development and deployment from cloud to edge and among x86, ARM64, because now we can use the same CPU and even we can use same software. We can use those traditional machine learning framework on the edge on the different architecture. It also can help us enable machine learning training at edge. We attach that cloud GPU to the edge. Even we can enable edge AI to the legacy edge system. It also can help us expand that SmartNIC view. More importantly, I think with our solution, we can build that machine learning AI workload towards that hybrid multi-cloud machine learning one key strategy of VMware. What's next? We are working on with some partners to build more use case on our solution. That's all. So if you have any question, you can reach out to me through my Twitter account or even my email address. That's all. Thank you. Thank you for your time.